Yeah, no, I might run out in the crowd and feel like, hey, I guess we're going to get started here. I'm Kristen Toll, and I'm with Microsoft Research. I'm director of the Natural User Interface team. And I am so honored to be here with so much creativity on the panel today. And when I talk about panel, I mean this is going to be truly an interactive experience. I'd like you guys to get up and approach these microphones so that we can hear you. And bring on all the questions that you'd like. On our panel today, we have the co-creator, like I said, creator, of the Worldwide Telescope. We have the creator of Kinect, Chris Wong, and then Alex Kipman. And then we have the creative director for Kinect Adventures. We have Darren Bennett. So today is the day for you to ask the experts about this. But before we start, I thought what I'd do is I'd throw out a question myself, just to kind of get us rolling. And what I'd like to do is ask the panel, what do you think the trends are in NUI? You know, speaking particularly in the context from Kinect, what kind of impact do you think that has on gaming, and what kind of trends do you see for the future?
Is that me? I have the mic. Can everyone hear me? Trends for the future was the question?
Trends for the future, yes. You don't have to repeat my question, though.
Yeah, I'm hoping that the trends is just that NUI of Kinect variety or other varieties like touch and stuff just go deeper and deeper and are used on every kind of thing that you want to do with any device. So right now, Kinect is for some, lighter, more family-style games, and that's going to hopefully people get deeper mechanics and stuff going with Kinect and use it for different types of experiences. Right now, it's kind of narrow, but it's going to widen out pretty soon and be all types of stuff.
Well, hello, everybody. Thank you for having us today on your last day of MIX. I hope you had a fun time over the week. To answer your question, to me, the trend is a trend that hopefully is industry-wide, and it's a real trend that says, hey, the point of doing the things that we're doing and seeing is a point of making technology disappear. And I think that as you make technology disappear, you really start changing the discourse from a world where, as technologists, we spend all of our time putting more gadgets and more gizmos in people's hands, and you move into a world where we actually remove technology. We make technology disappear, and we change the discourse from a world where humans have to understand technology, and we move it and we shift it over to a world where technology fundamentally understands us. So we've grown up in this world of having to learn technology. All of us were born and bred and had to understand that some amount of cause would generate some amount of effect. What it meant to double-click an icon, or what it meant to click on a link on a website. And I think the world that you see begin, or that Kinect can be a catalyst of, is this world where you don't have to do that. It's more about the analog world. It's more about the world that you and I live in, as opposed to this, digital 0 and 1 cause and effect world. Which is why in our world, you simply step in front of the sensor, and the sensor recognizes you. You don't have to tell it who you are. It understands who you are, and it understands the difference between you, your friends, and your loved ones. You can start moving, and instead of having to go through many layers of indirection that some designer somewhere figured out that you had to press a button in order to kick a ball, in our world, you simply just kick the ball and the right things happen. And finally, we have speech and voice and more natural ways in which we can interact with the system by just speaking, right? We like to say a lot that if you see something, you should be able to say it. Which is why you can say, in Netflix, Xbox pause, Xbox play. And I think as the trend continues, you really start seeing benefit and gain as you start merging these things together and using these different forms of both input, output, and really enabling things around the real world together. Right? To give you the simple example, I want to live in a world where it's as simple as pointing to something and saying, show me more of that. Now, saying something like, hey, show me more of that, there is no context for what you're talking about unless you see where the person is actually pointing. And then if you have that level of input coupled with what he just said, you actually have a ton of signal in this vastly large signal-to-noise space. And as technologists, if we can start figuring out how to pick up this signal in the noise, before you know it, you can make technology disappear, and you can create experiences that really allow anybody to just walk up to it and use it in the same way that they do in the real world, which is why one of the mantras of the Kinect team as we developed it and brought it to market was, hey, all you need is life experience. If you know how to do something in the real world, you should absolutely know how to do something in our world.
That's a great summary. I mean, why do I need to follow Alex? Let me add a couple of things because, I mean, I think we're all sort of in agreement with the future. But, being the token guy here in research, we're starting to think about the things that are, how do we make some of these things possible? Craig Mundy has talked about room computers and all the walls as displays. How does that happen? Well, when you start thinking about the combination of technologies that are manifested within the Kinect, you can see the pieces start coming together. If you look at things like the audio stack that I and Tesha developed, our Brainiac in audio processing, there's a number of really, really hard problems he had to solve, but the combination of all of those things resulted in a really unique sensor that can pick up audio from somebody, I guess, like 10 meters, 15 meters away or something like that, maybe not that far. But, when you combine that with the depth sensor and other things, we're essentially building a greater and greater understanding of the context of who you are, where you are, and what you're trying to do, establishing a better way to understand intent. And I think as all that data starts filtering into the cloud, we're going to be able to do a better job of getting to what I call sort of the concierge stage, where you can ask the computer for something and they'll tell you of certain choices of what it thinks you're asking for. And then as that model refines, then we'll get sort of to the Hobson stage, which is where it knows what you want in anticipation of before you even have to ask for it, and then presents all those choices and you just have to pick the outcome.
Mm-hmm. So just for those of you who come in, it looks like the room's about doubled in the number of people from when we started out. Just want to reiterate, there are 2 microphones here, and this is an interactive panel for you to be able to come up and ask questions of the creators of Kinect. And so feel free to do that. I'm going to go ahead and ask you another question, unless, there's a question right there. So, yeah.
Start the conversation off with users with disabilities.
And
where do you see this going? And could this ever get to a point where you might actually lock people with disabilities out because they can't interact with it as well?
Yeah.
Throwing it out there. You got voice and you got point and touch and whatnot. Just throwing it out there.
Okay, I'm going to repeat the first part of that question because I don't think it got captured, which is what are we doing about disabilities? And he's throwing out there, what are the ideas and the ways in which we're interacting in that particular space?
I think the palette that you create across NUI actually enables us to address accessibility in a significantly more profound way than you've ever been able to do it before. Take just Kinect, which is the beginning of the journey, is by no means the end, and the amount of letters that we get or stories that are told about people. And I'll give you 2 examples to just showcase the answer to your question, and then I can answer what we're doing to amplify it. Right, but I've gotten more than a few letters from military people, for example, that for whatever reason had the unfortunate accident of having any number of their limbs amputated, and these are people that haven't been able to interact with machines in meaningful ways. And the joy that they had when they stepped in front of the sensor and we actually finished their arm, right? And said, hey, turns out that we are actually pretty good at understanding the human body, and humans, more often than not, are well-formed. It's a predictable thing, right? So if I can see, say, your shoulder and part of your arm, I can project and actually figure out where your hand would be in space as you're moving. So now all of a sudden, a person like that can play volleyball, they can play ping pong. And those are entertainment experiences because we're entertainment people, but you can see how that applies also in productivity, in communication, and many other places. The other types of stories that we listen to a lot are people that actually have learning disabilities. These are people that have significant issues interacting with not only other people, but technology or entertainment or things like that. And there's more than a few stories of these people that for the first time ever, since they were born, were able to be entertained and interact not only with their family and loved ones, but with different type of entertainment experiences as well. So if I look at this journey, and it's this journey about more fundamentally understanding our world, the potential is magnificent. Accessibility tends to be something you have to explicitly think about because, again, you have a set of programmers that need to sit there and they have to program all sorts of causes and then figure out all the different effects. If you are creating a more noisy system, if you're creating a system that needs to understand everything that happens in front of it, you're giving it eyes, you're giving it ears, all of a sudden you get a whole new class of people that hasn't been able to, in our world, be entertained or in the more generic sense, use technology in meaningful ways, that now have are able to access these experiences for the first time. So I think the potential is tremendous, and I think that the implications for our industry are rather profound if you think about it right, and we do. Right? And we actually do spend time thinking about what does happen when, a person walks in front of the sensor and there's something that's not entirely perfect about them. And how do we handle that in a meaningful way that allows them to still have a very great experience? And with that, I pass it to Darren, who designs a lot of these experiences, and probably add.
Yeah, I mean, it's a really good question, and I think the thing I like about Kinect is it's a piece of hardware that you can write a lot of different types of software to accommodate a lot of different types of situations. And just like, I don't really have a disability example, but when we were creating the jump for River Rush, we've discovered that almost, that everybody that comes in is jumping in different ways, right? And so just that different way that people interact, we could craft the software and tune the software so eventually we get enough cases through that everybody's able to jump and be successful. And I think you could apply that same kind of, hey, test it on a bunch of people with different disabilities and just keep tuning in the software. I mean, that's the nice thing about software. It's just, malleable. And then just another thing on a little story about a woman that came into the user research sessions early on when we were making adventures with her son that had autism, and they had to do like therapy for like kind of like him using his body and actually coordination and exercise and stuff like that. It's really hard to get him to kind of participate and stuff like that, but when he got in front of adventures, there's something about that interaction that he was just compelled to kind of like do those motions that he usually can't do automatically. So depending on what it is, I think there's some real benefits to this type of interacting.
Absolutely. There's also experiences we're seeing around geriatrics, keeping people in their home longer, active longer. So I think we're going to see a lot of stuff growing in that particular space as well. And if you haven't seen the demo, there's a guy, actually, I just happened across when I was going to get my lunchbox today, who's standing there for the visually impaired. He's got a Kinect on his head on a hard hat. So, there's no doubt about it that the accessibility story is truly there with Kinect. You were next, so please.
Sorry for my English is not very well. In the same line of the last question, I was wondering what is really natural. I have some students that are deaf and they use a sign language to communicate to each other. And it's very difficult to everyone else to understand, but they seems natural to use this kind of language. I was thinking about what is natural if you have a cultural difference and another kind of difference. It's natural for some people to do things in this way, but in another country, in another place of the world, it's not natural to express this kind of same expression with the same movies or the same way of talking. Or I was thinking in deaf people because they have a separate word where things are natural to them, but it's not natural to us when we see someone with are deaf making signals.
Yeah. Actually, I can take a stab at that if you don't mind.
Go for it.
So, hush hush, there are hacks out there that people are using, but University of Georgia actually has a YouTube video up where they're actually doing gestures with sign language. And sign language in and of itself is a very natural way for people to express. It's designed for people who are children actually, who are speech delayed or are deaf, to quickly pick it up. So it is a very natural way of interacting, and certainly something that we'd be remiss if we weren't looking at. So, do you have a further question on that, or? Yeah. Okay.
Go for it.
Yeah, just one thing is I think with when Alex was kind of describing what the future is, where we start to understand more and more about how people interact in the context of different people, I think as that database starts to build and build and build, then there can be a translation that happens, you know, like if we understand sign language and you're interacting with someone that doesn't, we can put words up on the screen so they can read along while you're talking to them in sign language. So I think it's just a matter of time until people spend enough energy and time on all these different circumstances, and then we can start to translate them all for each other.
Yeah, and I would like to add that part of the journey is to say there is no single right way of doing anything. Right? This is my point about cause and effect programming and heuristic-based programming, where you, the developer, ahead of time sit and you say, hey, I am going to tell the user that he needs to press a button for some cause to generate some effect. And then you need to teach people how to use the technology. In our world, if I really mean what I said, which is technology disappears and it understands you, and believe you me, I mean it, that means there is no wrong way of doing it. I give you a very clear example in terms of what probably everybody here can relate to, which is driving. I could say that I'm creating a driving game, and I am going to come up with a gesture, because I'm the designer, you know, why not? And I'm going to say, hey, the way that everybody drives a car is like this. And, you know, if I now need to have everybody know that that's how you drive a car, I'm teaching them. They have to understand the technology. It's not technology understanding them. So if you actually start observing people as you start doing that, you start saying, come in front of the sensor and drive. And you find out that, you know, most people don't drive the way that I was showing you that people drive. A lot of people drive like this. So then you say, okay, which one is right? The way that I did it first or the way that they did it next? Well, we're smart, right? So let's go for both ways. I'll code both ways as correct ways for you to actually drive a vehicle. You bring people to test it again, and you find out that all of a sudden people are driving like this. So then you're like, okay, so all three ways of driving were correct ways of driving. I'm smart. I'll go code all three of them up. And then you bring people to the lab again, and you start finding out that actually, to your point, people have gestures that localize differently as you move around cultures and as you move around the globe. Turns out, and for this life of me, I still don't understand, if you go to Asia and you ask people drive like this. So the point is, I can go forever and start coding, you know, infinite possibilities of different ways of people driving, because the whole point of making technology disappear is that they're all correct. And this is where you start then shifting the world from this world of is either true or false. I either hit the gesture or did not, and you start moving into a probabilistic approach of the world. It's not about what you know, and you're never right. It really becomes about what you don't know, and you start expressing your world in terms of uncertainties. You start expressing a world in terms of probabilities of what could be. So as someone is sitting in front of it, you know, it turns out that driving and gear shifting are pretty much the same gesture. And so at that point, you're going to say, hey, at this point in time, in this frame of time, I have 88% chance that the person is driving in Asia and 20% chance that they're gear shifting in South America. And you start creating a much more robust way in which to handle our world. Right? Where we go wrong is if we use the technology and we try to make it true or false or yes and no or you must do the gestures the way that I came up with, right? And this is where, you know, another mantra that we shared a lot with the development team is let's not create religion in our stupid face, right? For us to come up with a gesture dictionary that we force onto people, we're not really doing anything to the art form. All we're doing is creating another level of interaction that happens to not have buttons that's using the person, but you're still teaching people how to use it. For us to live to the proposition, you have to switch thinking where all of these things are right. There is no right way of doing it, and you need to then create systems that become intelligent enough, much like you and me when we look at someone. All of those gestures I did, no human in this room would have had difficulty understanding that I was trying to drive a car. Right? So similarly, in our world, we have to approach the problem in the same way.
Just to add a couple of things. I mean, I'm sure some people here are thinking of NUI as natural user interface. I like to think of it as natural user interaction, and we're not just necessarily thinking about interface that we've been used to in terms of screens and mice and keyboard. And when you think about interaction, interaction can be defined in a lot of different ways, whether it's speech or having the computer understand, if I use that term really loosely, about what your intentions are, to try and adapt to that modality that Alex is talking about. The other thing is with the Kinect SDK, one of the things we're also hoping to do is the potential for malleability in these kinds of designing interactions that can be more suited to a wider variety of people than sort of the single or multiple interaction models that we're programming into these. So.
Okay, you and then you.
So let's say today I have a vision for an application beyond traditional gaming or entertainment. So today we have Netflix, for instance, enabled by Kinect on the Xbox. But as a third-party developer, you haven't given me a conduit other than the Windows SDK, which is obviously forthcoming, to create and deploy a commercial project. So is Microsoft's guidance for me that I should expect Media Center PCs to be reignited by Kinect and wind up in the living room? Or are you going to give me a platform to deploy my experiences on Xbox, which to me, I don't know, makes a little bit more mass market sense, perhaps for some users? I'm not sure. So how do you think about that in the longer term? Clearly it's early days, but how should we think about that approach and the path that you're giving us as developers?
I think it's a great question. There's obviously no new announcements to make here today, right? Besides the announcements you guys already heard, which is, hey, Kinect launched November 4th. We all know, love it. We're going to be launching later in the spring on PC to enable a whole different genre of enthusiastic academics and set of people to use it. Focus is important. If you're trying to make science fiction into science fact at the clip that we're trying to make with this, it's important to keep the team focused, and it's important to be incremental about it. Our first focus was to start the revolution in the living room, focus primarily on entertainment, where the ecosystem, it's a closed ecosystem for first and third party developers on our platform. Less than 9 months later, here we are, and we're already saying that this thing is going to show up in a much more open platform on PC with different development tools to support a whole different type of programming. That journey will continue, right? And I'm not going to share anything that's not shareable today, but the perspective of the company, the perspective of Microsoft is this trend is historic. And you will wake up in a world where you're going to clearly remember that there was a world before it and there was a world after it. And the thing that Microsoft does really well, the thing that has made us the great company that we are, is that we know how to build platforms and we know how to foster amazing ecosystems. So that will continue here, and you will continue to see progress in that journey. But focus is important, and we've been very deliberate about the cadence in which we start exposing these technologies to the outside world.
Okay.
So, talking about your vision of where you want it, where you point at that, and you tell me this, that very natural interface. It's a lot different, I think, from like with the World Telescope. It's amazing, but it's still very gesture based. And so, do you think is it learning the new technologies? I mean, like the stuff you mentioned that Ivan developed, it's a year old or whatever. Is it learning how to use this and develop the systems to make it more natural, or is it still a lot of hurdles on the technology realm, or is it just, the mouse has been around a while. We know how to program. So
I'll give you my platform answer, then I'd love to hear from these guys on the consumption end of that story. I tell you that the way that I approach platform building, the way to think about it is that at the end of the day, we're creating a palette, right? Think of it as, we're creating paint colors and paint brushes. And then everybody here uses that palette. They're the painters, they're the creative people that are painting brand new experiences that haven't been painted before. Now the palette is brand new, and the palette is something that you continue to make progress on. You'll come up with better colors and better paint brushes. But it does take time for painters to also learn how to use the platform, the palette. I give you examples from our world, from gaming. If you think about Xbox 360 as a platform that launched in 2005, and if you think about that, by design, the console industry doesn't actually change the hardware. The hardware today in 2011 is the exact same spec as the hardware that we launched in 2005. However, the games are not, right? If you compare, just take any franchise for the gamers in the audience. You take a, Call of Duty 4 that launched on the 360 at launch to a Modern Warfare 2 or Black Ops. It's the same franchise on the same hardware. The games look nothing alike. Why? Because people learned how to use the palette evolved, and over time, things became more attuned to what the palette was meant to do. Same thing with Halo, right? Take a Halo 2 to a Halo Reach. These are magnificently different experiences. The palette progressed, but it's the same hardware. You're going to see the same thing happen with Kinect. Kinect is a transformational new palette that will continue to evolve. And as we continue to evolve it, the people that take advantage of it, that paint with it, will start using it in more meaningful ways. The only thing I can tell you is that, Kinect experiences in year 3, they'll look nothing like Kinect experiences on year 1. And that's just part of building a whole new ecosystem and building a whole new way in which we can approach application development.
I thought that was a great answer, Alex.
Okay. I would like to just add one thing to that, and that's, being in research, we can't hire all the smart people in the world that are going to think about all the different ways in which this can be done. And that's actually why we're releasing an SDK. We want to put that out to the enthusiasts. We want to put that out to the academic community and see what they come up with. And then, we can think about where we head with commercialization. But right now, it's really that green field that you guys are going to get to go out and play in and dabble and use the palette, as Alex likes to say, to create things that we won't even think of. I mean, that's the whole point of it. The point of it is to get it out there and get people using it and seeing what they can develop with it.
Along the lines for Kinect, have you, and it's one of those palette things, I really like that analogy, in terms of using it for training, and also then the next extension of that is could you use it to help train not only how to perform a task, but how to do it ergonomically in the most ergonomically efficient way, so that if they're doing it wrong, you could give them feedback and it can actually figure out the ergonomics for that person?
Absolutely, right. And I would say that there's a whole genre of entertainment experiences that we already launched around fitness in particular, where you see that happen, right? One of the beautiful things about having a device that's as precise, right, that where the brain behind Kinect can actually track all the joints of your body within a centimeter of precision to where they actually are within the inside of your body, is that you can do precisely that, right? And if you look at the, probably my favorite example is Your Shape Fitness Evolved, which was one of our launch titles by our friends at Ubisoft. You'd find that, while you're playing Tai Chi, your Tai Chi instructor that's virtual is doing precisely that, right? It's saying, hey, your arm is 2 centimeters off to where it needs to be. Make sure you raise your arms, and once you hit the pose, make sure you hold it, right? So to your point, the palette has the expressivity in it to allow for that level of precision of experiences. Now, you'll get a range of experiences, right? There's some experiences that are made to be less precise because you want people to just have fun, right? At that point, you're going to have more of an arcadey feel to it versus more of a simulation feel to it, right? And in the simulation end, you do want to have that precision, either because of ergonomic reasons or for fitness reasons or other reasons. And I think you'll see an interesting range between all of those things.
And then are you looking at, along that lines, being able to do data collection on, for example, when someone first starts the training, so that you could track, for example, their improvement in an ergonomic profile?
Sure. We need to separate training from the perspective of what happens in people's homes to what we actually do in the labs. Right? The way that we actually understand humans is based on probably the world's most sophisticated series of algorithms, which includes a large portion which is machine learning based. And the machine learning base is probabilistic based machine learning, and it is based on training. Right? It's based on showing it. If I just think about it for a minute, let's go walk through a paper napkin exercise in this room. If I want to track a human to the level that we are talking about, you have to think about, okay, so there's about 20 joints that I care about in your body. If I think about, the different proportions of male to female, to children, to adults, to fat people, to skinny people, to people with baggy clothes, to people, dancing naked, to the different living room conditions, from the small dorm rooms to the large, living spaces. It doesn't get very long for you to get a search space that's 10 to the 23, right? It's 10 with 23 zeros next to it. It's a fairly large search space. So from that perspective, you're never going to be able to code up all of these choices, which is why you land on the machine learning-based approach, where you're essentially allowing the system to look at the world and not know it because someone programmed it, but be able to look at it and say, based on the historical data, what I have seen in the past, I know that it's 80% probable that the thing you're looking at, that pixel, pertains to a wrist. It's 40% probable that that pixel belongs to a hip, and on, right? So from that perspective, to continue to evolve the palette, we do require internally to run through terabytes of data of just running different people through it and observing. Right? And then that data gets transitioned into just creating a richer palette that people can use. Now, with that said, in people's homes, we are not observing people and sending data back to Microsoft to process.
And the last question is, are you looking at expanding Kinect to be able to track large animals? For example, research in horses is one of the ones. Michigan State University has a program for, and they've been doing glue the 50 little silver reflective balls on the horses and so on. And another application for being able to use it for larger bodies would be agriculture.
Sure. Part of the reason we're releasing an SDK is to allow people, particularly in academia, to use the rich set of eyeballs, ears, and brains that we've created to extend it for things that, perhaps are not, the things we're focusing on right now, from, tracking horses to elephants to whatever have you, which I think are very valid. But in the world of Xbox, for example, I'm not going to get a ton more sales of the system because I can track horses in real time. Now, the framework we've created, right, the pipeline we've created to track humans is something that is largely extensible to any number of things. It's a fairly generic pipeline that allows us to, based on training, to understand any number of different things. Right? So once we start making these tool sets available to the larger community, I do expect that before you know it, we will be tracking horses. Not because people at Microsoft, Xbox, spend time tracking and training and optimizing for horses, but because we made the palette available for people like yourselves to do exactly that.
It's awesome. Thank you.
Hi. The trends in electronics are generally toward miniaturization and just combination integration. Right now, the Kinect hardware is integrated with a gaming system, but I'm interested to see what kind of applications you could see with that hardware, integrated with other things like the helmet. I could see that being, kind of compressed in the future into almost a sunglasses form factor or something like that. But just what kind of combinations do you see in the future, possibly, with the hardware?
Well, I think one of with your sunglasses point there, kind of gets to it, is one of the things that's, when we talk creatively, when we're coming up with new game ideas, is like, I wish I could just snip this cord off of this thing and go running around in the real world with it. So I think stuff like that is really exciting. Yeah, making it small enough to be portable is an exciting idea, and just more of them, and more range, and just being able to move out of that space and get way more people into that space. Just that's what I'd like to see with it, is just basically I can interact anywhere like I am in front of the Kinect.
So when they were developing Minority Report, the movie, they brought these academics together for a weekend and did a lot of scenarios about the future. And a lot of them have to do, if you remember the scene when Tom Cruise is going through the stores and on the subway, and they sort of knew who he was, and they were targeting specific kinds of ads. You can sort of imagine sensors being everywhere, and just your presence and the sensors you have in your mobile device, as well as being able to sort of determine who you are and where you are, I suppose. You can imagine these kind of sensors being everywhere. Of course, that brings up the big questions about privacy, and those will probably come up long before we'll see scenarios like that. But they'll be in displays, they'll be in all kinds of things. In the walls, because walls will be displays as well.
I know you've been waiting a little bit longer, so I'm going to go with you and then I'll back over to you.
Thanks. How much fidelity will there be, excuse me, between the Windows SDK and the current Kinect SDK? If I'm developing right now on Kinect or for the Xbox, would it look similar?
Can you just repeat your question like a little louder, closer to my microphone?
How much fidelity will there be between the Windows SDK for Kinect and?
So make sure I understood your question correctly. What is the delta between the SDK and the console?
If I'm a developer, will the APIs look the same?
Yeah, they won't. They won't right away. Right. This is a matter of, again, trying to hit you to allow the community to express itself as fast as possible. Right. So it's a journey, and the journey begins. Eventually, those things, the feature set, the flexibility, the ways in which we interact with these things, I do think will become the same, right? And they will become standardized. The platform we created on the Xbox 360 is something that we spent, a good portion of 3 years of our lives creating. The Xbox 360 is a massively different platform than your x86 architecture on PCs. To my point that the Xbox 360 is an amazingly beautiful, sexy device, but was created in 2005, and it cost $199, right? So just imagine that you have about the same amount of processing power as your modern-day laptop inside of that machine. And yet, the games on the 360 still look better than your $6,000 PC. Why is that? It's because we go very much against the metal, and we take advantage of every single little 0 and 1 on that platform to make sure that the thing performs to the clip that it performs with. Take that for the Kinect work that we did on the platform, and if you think about, hey, I'm in 3 milliseconds, translating 640 by 480 pixels from pixels of depth to probabilities distributions of body part after I segment and after I graft skeletons on top of it, and I do this in 3 milliseconds or less. That's a very optimized to the core, to the bone of Xbox 360 code. The amount of time it takes to go port that to an x86 architecture and to make it show up to the level of depth and expressivity as you have on the Xbox 360 today is something that takes time. And if we waited for that to happen before we released anything, it would have taken even longer, right? So from that perspective, it's a matter of taking focus, being incremental about it, and approaching it as a journey. I'll use the example as voice as a great one. Right? There is a ton of science fiction turned science fact in our voice recognition pipeline. Right? It's the first non-push-to-talk system that can be on 24 hours a day, that can pick noise over 80 dBs of ambient conversations. It can beamform on people that are sitting 4 meters away. It's a thing of beauty. And it's something that people have not been able to get access to on PC yet, and it is something you will get day one on the Windows Kinect XDK. And there will be parity in that piece from what you have on Xbox. Again, day one, no, you won't get exact parity, but it's a journey, and you have to start somewhere. Over time, as we continue to invest in this journey, it makes total sense, right? I'm even going to say, I'm looking forward to the day when I can do Kinect on my Windows phone, and there's parity of APIs there. Will that happen? Sure. Will it happen tomorrow? No, right? And it's a matter of being incremental and approaching it as a journey.
Gotcha. So then things like just API nomenclatures and things like that, you could expect consistency between the two, but
perhaps not, because perhaps that doesn't make sense, right? The standards we have for API design in console are different than the standards we have in, say, .NET or in C++ even on PC. So we could artificially make them the same, but we'd always be alienating one segment of our customers. Right? Our Xbox developers are expecting a very different looking API set. So Kinect was created to be consistent with our XDK, which has existed for a very long time. On PC, we should and are going to be consistent with the APIs that all of you guys are familiar with. Right? So then by definition, there is disparity between the API signatures that you will see, and that's okay because there's different types of people programming to these different things. Over time, if I prorate to the infinite future, I do see consilience of these platforms. Right? I can say, hey, I sure hope that 100 years from now, there is no such thing as a PC and a console and a television. It's all, one set of devices that you're carrying around with you all the time. And in that kind of fictitious future, sure, APIs will be consistent. But as long as you have dramatically different platforms, it does make sense to keep those API signatures consistent to the platforms they're being released on.
Thanks.
Okay.
My question's very similar to his, but more so to do with what we can track. On the Xbox 360 now, we can only track hands, maybe the head moving, jumping up and down. But what will we be able to track on the SDK for Windows when it comes out?
You hurt my feelings, sir. This is going to be my first tear of the day. You can track dramatically more on the Xbox 360. As I said, if you were to graft on the human body, you can track 20 joints on your body in real time per frame at 30 frames per second. If you were to draft, you can track tip of hand, you can track wrist, you can track elbow, you can track shoulders, you can track several joints for the hips, you can track kneecaps, you can track whatever this thing is called in English, you can track tip of toe, you can track several different points for the neck area so that you can keep track of rotation and translation for the head. With features like Avatar Kinect, which is released soon, you're going to find out that we're tracking eyebrows, we're tracking eyeballs, we're tracking your mouth, we're tracking your emotion. So I would say the expressivity and richness of the palette on the Xbox 360 is world-class, and you haven't seen anything in the world before or since that comes anywhere near the amount of things that we track in real time. The PC version, day one, will not have that level of expressivity for all the reasons that I talked about before, but over time you will start seeing these things get ported over.
May I rephrase and just add a little? On the Windows machine, everything is pointer-based other than the Maps applications and the custom applications that you've showed here. We as developers would probably be more interested in being able to track fingertips, as we much do on multi-touch displays now. Is there something that you're going to allow for that in the SDK?
Well, again, the whole beautiful thing about having an SDK is that it allows everything, right? The reason I love the art form of software engineering and why I joined it is because the only thing that binds you is lack of imagination, right? If you can think it, you can do it. I'll give you the very specific example of why we don't support fingers in the living rooms. In the living rooms, it makes very little sense. Turns out that when you're trying to deal with the real world, physics laws are laws. They're not suggestions. Light travels at the speed of light, and it decays at a square function from the perspective of the sensor, which means you're losing precision of what you can see at a square function as you start moving back. So I can track fingers no problem today with a level of precision you couldn't imagine, but I can't, as a platform developer, think about it in those terms. I have to think about, what is the finger at a 4-meter distance of a child, and I will ask you the question then, which is, hey, if you, human person you, which your brain is significantly more sophisticated than my brain on Kinect, if you were to go look at a kid's hand at 4 meters and their little fingers movement and the level of self-occlusion that occurs when they do that, and I said, can you see the fingers? You wouldn't be able to. Right? So for me to try to expose that feature set in the living room would imply that people would start getting tortured experiences, because it turns out that there's not enough signal in that signal-to-noise world. Now bring that back. That's mostly, people are going to be at least 10 feet away from the sensor. Bring that back to PC land, where people are usually staying about 2 feet away from the sensor. Think about that from the perspective of the PC, where the angle in which you're seeing something, since you're in front, floating in front of a monitor or something like that, you actually can see the hand, and it does make sense for you to start manipulating things with your fingers, right? So platform gives you the expression to be able to do those things. We don't do it on the Xbox 360 because it makes very little sense to do that in the living room. We won't make that feature set available day one on PC, the feature set of, hey, we coded ourselves finger tracking, but the SDK allows you to go code finger tracking, right? As a matter of fact, if you go look at a lot of the enthusiastic academic research in the space, since we launched Kinect on November 4th, you do see that people are using different ways in which they can track and keep track of things, which include, I believe there is interesting research out of MIT on Kinect that does finger level tracking.
Thank you.
My question, I know this is too early to maybe ask something like this, but regarding hardware for maybe for the next Kinect version, because right now some of the I won't say problems, but some of the things that people are experiencing have to do with the camera quality. If you want to use a live video feed on top of your motion detection and you want to use a Kinect camera, and people are asking for HD capabilities as well as a light sensor alternatives. So because you guys are using infrared, that might not work as well in certain light conditions or outdoors. Are there plans to use different hardware in the future? How would you just address this?
Yes.
Can you give slightly more insights into that?
No. Well, the answer is nothing to announce here today, right? But hey, turns out that we're pretty passionate about this thing called Kinect that we launched, and we do believe in evolving it over time. We have people that do nothing but build hardware at Microsoft, and they still have jobs today, right? How about that for an answer?
Thanks.
Okay. Please.
You mentioned earlier that you guys had to be focused, and your focus is entertainment. Do you know of anybody that's doing things with applying this toward line of business systems? And if you don't, what are your thoughts about being able to apply this to business systems?
One of the areas that we were showing in our booth was showing data within Worldwide Telescope. And one of the interesting scenarios we were thinking of is having groups of people that are essentially doing exploration of 3D data over time in a very, very large display with multiple people both annotating, speaking to be able to annotate things, taking control of that data and to explore it. So I think there are, significant opportunities in the future as we start thinking about large displays and the amount of data that we're trying to comprehend that's coming in from the proliferation of sensors and other things around business.
Yeah, I mean, I think with something as new as Kinect is, from a technology standpoint, entertainment is a good place to start with that technology, because creating fun out of it, there's no kind of baggage of productivity, speed, and all that kind of stuff that you have to deal with. So you get it out in the market, get a lot, learn a lot in that entertainment thing, and then the natural place for it, I think, to go after people learn a lot about it in that space is to more that kind of productivity space. Thanks.
Okay, I actually want to add a question as well. What was the hardest thing about developing Kinect? Yeah.
I think the hardest thing about developing Kinect was probably that Kinect was developing while we were developing for it. So it was a moving platform as we were going, and so we're trying to keep up all the time, keep current with the latest hardware and the latest, skeletal tracking and all that kind of stuff, and it was always moving. We'd get somewhere, and then we'd be like, oh, we got to update, so we keep going, and it breaks everything, and that was pretty much the cycle all the way through. So it's pretty hard, worked on Adventures, which is the pack-in title, and I think just keeping pace with the hardware guys was probably the hardest part, but, that's what you have to do when you're building something for the first time.
Okay.
Based off of what the people have asked, they've asked about this type of application or that type of application. What type of application do you see as the first set of applications to be developed by us?
You mean on the SDK?
Yes.
I tell you, the one that I want to see personally is the one I haven't imagined yet. Every day I wake up, I go to YouTube, and I'm like, holy shit, look at what they did with it. That's so cool. I want more of that, right? I can rattle off probably hundreds of things I'd like to see done with it. But I tell you, the point of creating palettes is to see the wacky, cool painters and what they do with it. And in a way, my dream Kinect app is the one that I haven't been able to dream up myself yet, that one of you will dream up once this thing actually gets exposed.
No? Okay, are there any other questions? All right. right, well, maybe we'll wrap up a little bit early, shall we?
Sure.
Okay. Well, thank you for coming. Appreciate you coming and being interactive with us today, and look forward to having you download that Kinect SDK. Again, that's going to be available from the Microsoft Research site. You just need to go to research.microsoft.com and then search for Kinect SDK. Thanks so much.
Gamble, gamble.